Let's see if this is working. Hello everyone, just trying something new here. Spontaneous, really late at night, so we'll see how many people's actually up late at night here. So nothing too serious, as you can see, just experimenting with different setups here with the camera, because people were saying, hey, you should have multiple views when you're showing stuff, so we can see better. And I always have a hard time trying to show the camera and then zooming in and then showing the whole picture. So this might work better. So it's either going to be really, really annoying and everyone's going to complain, or this is a brilliant idea and everyone's going to love it. So essentially here is like basically the table if I want to demonstrate something here. And yeah, so you clearly see from another camera what's going on instead of like being really far away, I guess. So hello everyone, and now I could actually interact because I'm in front of the computer, right? A little bit more, such as it is. So with that said, I don't know if you've been with me. Anyone who's been with me for a while, I've been talking about the, always wanted to, since ChatGPT about a year and a half ago started centering all the interesting personas like Tom Beard and Tesla and things like that. As much as my Tom Beard AI works well, I'm still waiting one day that ChatGPT is going to null it or something, nuke it, whatever. I'm really surprised it actually still works, but as it still works, we still use it, but it's always having to tune it once in a while because they always upgrade their algorithms. Every time there's a new version, all of a sudden it starts acting up, and I gotta go in there as the creator, change a few words around, and poof, we're good to go again for a few months, until they actually decide, or maybe too many people start using it if it gets popular. Whatever the case is, it doesn't let me do anything like have controversial topics with a persona like Einstein and all these things that I had. And it just refuses to talk about anything unconventional for about a year and a half. So I always said I wanted to make my own AI system. And I finally did it, and it's working pretty good. It's all in beta, by the way, just basically for fun. I've got the link there, typewrite.social with the port number 8880. So just running here at home for the moment, there's some really interesting models that you're not going to find on ChatGPT that are pretty impressive. Even not just Alt Energy, I thought even Hutchison, there's a John Hutchison model, there's a Tom Bearden with all of his work. There's even a Joel Legacy model that has all the data of all my videos. So if you have a previous video or project, you can just go to the Joel Legacy Energy Explorer and ask it a question, and it will know what video you're based on a few keywords and give you whatever it is. So it's like a help for all my previous videos, right? That all the questions I can't really answer, you can go on there now and ask the question, and it's going to think and refer to the transcripts of those videos all loaded in there. Another one is just a generic DeepSeek is the big thing, right? The DeepSeek model. So I have one on there that's been fine-tuned for generic Alt Energy talks, not specifically Tom Bearden or Bedini, just a wide open, uncensored, just Alt Energy, which is great for thinking skills. Believe it or not, even a UFO one. So yeah, a lot of fun with that. And it seems to be working. Hopefully it doesn't crash or anything, but it's all beta, just something I'm trying for the moment. And if I could fine tune it, like I said in the description, have it in the cloud, something in Docker or something, and run it off Google. I don't know. But there's a start, at least it's working. And I'm learning about it and the sharing in the meantime. So if it can help anyone, right? So again, back to the place. I hope everything is starting to look better and more friendly to the eyes. So Tom Bearden GPT has done surprisingly well. If I had a Raspberry Pi, I'd make one offline. Yeah, it's really, really good, but the Raspberry Pi, you got to run like the, I think the 4B models or the 2B models, even, there's even special small ones and for embedded stuff. So I don't know how well their conversational skills are, but definitely keeping an eye on it because I thought of that. A little Raspberry like hey, Alexa, but with a little Raspberry Pi preloaded with Tom Bearden. You know, this is before I actually got involved with the company. I was looking for donations and so some way to make a little bit of funds here for the research and send these off for $100 or something, right? As a digital assistant, as a Tom Bearden offline kind of thing, but never got quite that far. But it was something in the back of my mind saying, "Geez, if it's almost there, right?" So it probably will be very soon. Yeah, yeah. But there are various enhancements to make it all work on the Raspberry Pi. If you want to put little adapters and things on there, you can even borrow the GPU, well, the GPU-ish like chip of many home routers these days that flash with Linux, and you can piggyback basically AI on that, which is kind of weird. But I mean, people are playing video games off the GPU, which is kind of funny, which is just like a route. It's your router, but they don't. It's not intended to run GPU tasks. But of course, the hacker community found a way to do that. Oh well, whatever works, right? I mean, so yeah, I mean, I'm wondering how many people actually will randomly watch at this hour. Here it's pretty late. It's basically 11 p.m. And but who knows? Sometimes people, that they're late, and then some other parts of the world it's really early. Who knows? So, um, yeah, I just wanted to plug that in there about the AI, how I think it's really cool so far, and it's working pretty well. And yeah, sometimes I run out of things to say. I'm just looking behind me. Everything is so neatly organized here. I want to like get into something. So many things to try. But then if I got everything cleaned up, right, I want to start something that's going to look all ugly because it's going to be a mess once I start working at it, right? So, yeah, make the place a mess. But I guess that's part of the experimentation and learning. And I don't see many workbenches being very neat. If they're really neat, there's usually a problem, right? You could probably say there's something, this guy doesn't know what he's doing because he's never out there on the bench if it's neat. If it looks really, really messy, then the person knows what they're doing. That's half a joke because every time I organize myself, folks, like behind me, I got all this all organized, all my resistors, all my parts labeled in K, and these cabinets here behind me, capacitors, resistors, diodes, you name it. But now that it's all organized, for the life of me, I cannot find anything. It's like, oh, I need rectifier diodes. I look half an hour and everything is all labeled and properly placed, and it's like, ah. But before it was all like in a big box, just random parts, and basically somehow I knew how to single them out of everything else and find what I was looking for. But anybody else who would have been in the room would have been like, "Oh my goodness, this guy is freaking haywire." How does he know where everything is if it's all in the same box, tangled with wires, mind you, and everything else, right? So I got it all clean and can't find anything. I'll get used to it. I mean, you got to be able to use the space you have to work with and be grateful for what you have and take advantage of it. And like I said, this used to be an office in here, and don't want to keep repeating myself about my loss and everything. But being one less person in here frees up space, right? So it's a work in progress, and keeps me focused and making use of, you know, what would be essentially wasted space at this time. I said, perfect opportunity for me. Always wanted to basically have the home set up. I still can't do crazy things like, high voltage, high current, no proper grounds, and all this high advanced anti-gravity stuff. Even with my Don Smith stuff, I was getting close to the end with the company, what I could actually do at home. And that still stands because, but they're working on that. It's probably looking more and more like Timmins is going to be the area for commercial space for the company and office. We want to get into like 3D printing and all that sort of stuff for our modules. And obviously, don't have the room to do all that here, but I still want to keep myself busy during my private free time, and it's my hobbies, and I'm into everything from radio broadcasting to ham radio to crystal radios to you name it, right? So always wanted to have my little space for a while. And again, like power cells, speaking of power cells, I think there's cleaned it all, and I got all these racks, and I think there's, oh, yeah, there's a few power cells here. Wow. This one here is all over a year and a half, over a year and a half old, right here. And it probably still puts up power. I'm going to put this on 2 volts here. And I've got a piezo plate in this one. You don't see it here. But in between here, there's a piezo plate. Just an experiment I was trying. So it's a year and a half old, basically. So it's been in my cupboard ever since. And as you can see, no corrosion. Zero corrosion. It's almost 2 years old. And I'm using this just this component here as an electrode. So let's check it out. So here's the top part. Oh, there it is, 0.6. 0.6 of a volt. This one here. And there's another one of the first ones. Oh my goodness, you guys probably remember this one, right? This is going on 2 years. No corrosion at all. And this was just a piece of foil. Can you imagine? So let's test this one here. Did you see that? 0.8, 0.9, 0.97, almost 1 volt. I don't know if I can, I don't know how clear that'll go in the camera. So I'm trying to hold the meter here. Some, I don't know if you can see that. I'm trying to hold it here. There it is. 0.966. I don't know how clear that shows up on the meter. If I bring it closer, I'm gonna hold this side on with my hand. Bring the meter like this. Now if you see it there, 0.1. You see that? It peaked at 1. So almost 2 years old, no corrosion. Like everybody accused me of, the first week I built these things. Oh, it's a galvanic cell. You did nothing new. You did nothing new. All the trolls, right? Grumpy old mans. Grumpy old ham operators. But yeah, it still works. And that's just one of many variations, which in a way I'm not really surprised. I knew it was going to work based on all the research and everything I've thrown at them back, months and years ago now. Still works fine. But that's very interesting because they have very little current, but that could be a potential well. Getting into something. Now I'm getting all excited and I'm thinking of things to do, right? This is what originally fascinates me. They keep giving you a potential for very, very long. It's not very much, but you can put them in parallel, you can put them in series, you can change your potential that way, or you can be clever with them and do like Tom Bearden was saying, you use it as a dipole, but you don't collapse the source. So how can you kind of sort of do the equivalent of open looping it? It would be essentially through a transformer, right? You pulse it. But the issue is they have no oomph like current to make it through the low impedance path, right? Everyone would think, oh, we need a secondary, we need a primary and secondary transformer setup, right? So by definition, whatever coil you're pulsing into is your primary and they're feeding off your secondary, right? But the issue with one of these cells here is this is a very high Z effect. It's high impedance. What happens is you put it on the low impedance side, you do the equivalent of shorting it out. So it would be like I said, shorting it out. So after like a second, it goes. But what's interesting is as soon as you let it go, it bounces back up, unlike a regular capacitor, which would just remain flat, right? But needless to say, if you're pulsing it, even it takes you flatten out because you're shorting it, essentially, because it's a low impedance or a low Z. So there are ways to deal with that, I guess, right? So what you want to do, like Tom Bearden say, is you keep the potential well open. You use it as a potential well, and we feed our load off the gradient difference instead. So we use an alternate path for the work is what we would do. So for this to work, you would feed I guess, a transformer to step it up to create that very high gradient difference for free. But again, it's like a paradox, right? Where it's a high impedance thing and we driving with low impedance side, right? Because you want to go high voltage. Because we have like 1 volt to work with. If we do it in reverse and so like if you want to try it, you could run it in reverse and pulse the high impedance or what you would consider the high voltage side. And you'll notice the cell doesn't react the same way, it doesn't dampen out. That's good, but you might get maybe 0.002 of a volt on the other side because of the winding ratio. It's not what we want for this application. We want to create a potential gradient difference, a very high, we want to feed off the gradient difference. And we can do that for next to listening to Tom Bearden, we can do that for free, basically, or next to free by the help of the environment. Like these power cells here, essentially, here it is. Here is our potential well. Tom Bearden tells us, don't collapse the source dipole. This is our dipole. It's continuously giving us this 1 volt potential. Now, the silly thing we want to do in electronics is close loop this, short it out, and like I said, vroom, right? But we put a high Z path. If you close loop a high Z path, even though it's closed loop, it's like being tuned with the impedance that the cell expects. So in other words, even though you've got a closed loop, the cell hardly feels that it's connected. So if you pulse the high Z side, and then there's another high Z pickup, then you get your high voltage for very little. But the problem is to be able to do that for a high Z to high Z transfer, you need to have the resonance tuned effect for this to transfer efficiently. And for that to happen, it won't be like 2 or 3 pulses a second. You need to go high frequency. And again, you're into the dilemma. This may not support that such fast regauging, right? So there's an actual fix for all of these issues if you think carefully. All we have to do is this wants that high Z path. So let's just give it the high Z path. We could either A, add a very, very high resistor and then keep going in series and then true or low Z and then back out. Now you pulse it through the very high resistor. This hardly feels it, but you're still creating those high voltage sharp spikes through the transformer, which will then trigger the secondary system to bring up those high voltage. So there you got it, right? So that's the thing. Or you could create your high Z by putting a, let's say, a microwave transformer in reverse on the high Z side, and then keep going, and then the low Z of a regular transformer, and that's the step up. So you're using the first winding as the inductive version of to bring the resistance up, right? What's interesting with that is you could have, by having a coil there, essentially you're creating additional tap for magnetic resonance. So either you can constructively interfere or screw things up, but it's interesting because if you add a coil, it gives essentially an extra energy tap if you know what you're doing. But that's totally optional. You don't need to have another coil. You can simplify it by just having a very, very, like in a mega ohm range resistor in series with the low winding. The low Z side in series with the high impedance resistor will give you the equivalent of that high Z. So the cell, when it gets pulsed. But how's a way? I always thought maybe use maybe a clock needle, make an analog. Those work off a 1.5 volt battery. It's mechanical for like 6 months. A dead battery will run it. And that could trigger this thing into your high Z loop. And as exactly meet the Tom Bearden specification, this becomes your potential well. We're just sipping it. We're not shorting it. We're just sipping it, using it as a potential. We're boosting it and using it as a potential gradient. Now on the output side, you may have 10, 20, 30, whatever. Now that against real ground becomes a gradient difference. Then you can start doing what Don Smith was doing from point A to point B, and then your load in the middle. Because you know, you always want to equalize. So then you create that exactly what Tom Bearden was saying. Let the gradient difference power the load. And that's what he means by the environment is what wants to equalize everything. And that's how it's the displacement effect that gives you the equivalent, as thus the name in capacitors, they call it displacement current. It's not real current, but it gives you the same effect as real current as far as work is concerned. Because essentially, what Tom Bearden was trying to say is the vacuum doesn't care how we arrange the load as long as we make that gradient difference, right? I wonder if I could actually, it's getting pretty late. I'm just going to read some of the comments here. I'm just rambling on and on, right? But, so yeah, anyways, maybe I can show you what I mean. I've got all this stuff here, so don't mind. There's so many goodies. I think I can show you. This one here. So, flat coil, I don't think I'm gonna. Ah, right here. Right here. Check this out. High voltage transformer. I might be able to demonstrate something crudely here. Let's see what else I got in the goodies box. The goodies box. So what I want to do is I want to create that high Z path, but I prefer using coils. I said resistors can simplify, but so we're going to use this one here. This is going to be essentially a resistor. Sounds silly, I know, but you have to think a little bit outside the box when you work with this stuff. So the idea is we are going to go on the high voltage side here, which would be the high Z, which is the red winding over here. Or should I say it like this? So I'm going to want to plug my cell. We're going to have to pulse this manually. So let's see. I got some clips here. So my apologies if nothing works, by the way. This is completely on the spot, unscripted. And this is where sometimes people make the most fool of themselves when they're explaining something and all of a sudden nothing works right. But you know, I'm trying not to do that. I usually know what I'm talking about here because this is nothing new. I just want to demonstrate it to prove my point. Since I'm fascinated that my power cell still works like going 2 years into it. So I want to show you how this could be basically your eternal potential well, like Tom Bearden was saying. So we're just going to hook up the electrodes. So this is my high Z path, but we're keeping this one open for now, right? We're just using it to create a high Z path into the primary of this one here. Since I'm going to pulse this myself manually just to demonstrate, you know, I can just go like this. So this is my low Z side, the low impedance winding, your primary usually. So this is what we want to be able to excite our higher potential. But now we won't stress as much because we're passing first through the high Z side, which creates naturally a high resistance without a resistor. So we're essentially tuning the loop to what our source is expecting, a super high impedance so we don't collapse our dipole here, like Tom Bearden was trying to explain, and we pulse it to keep the loop open. The terminology is actually in plain English if you understand what Tom Bearden was trying to say. Now, technically speaking, if I strike this here repeatedly right there, I should start reading high voltage on this side. So what could I do to show you this? I could maybe put a rectifier on a capacitor, or maybe scope it. What do you think, folks? Should I just hook the scope up, or what? Getting late, I don't know, but people could always watch. I want to I'll try to scope. I think I have it there. That USB cable is all tangled up. Come on. Hopefully I got the right power adapter for this thing. Again, my apologies if nothing works. I hate on the spot stuff. But some people keep saying, you know, oh, we want to see what you do when you're just doing stuff randomly, right? So here it is. When I get in a random mood, turn this on, hopefully. Got enough power. Is it even connected? Oh my goodness. I'm just looking for the power adapter. I just moved everything around and this might not be the right. This is not the right. Unscripted, folks, right? There's the power, it says. This thing might not be giving me much. All right, I could always connect the old scope, I guess. Because I think I've got the wrong power adapter, believe it or not. I have to search for it. That's the problem of moving everything around, right? You know? Ah. Absolutely no response, so I'm gonna have to look for that because I think it's actually right here. DC input. Yeah. All right, scratch that. But what I can do, let's try something. Got a rectifier here, a capacitor. I'm gonna try something. It's very silly and quick, but it might demonstrate exactly what I was talking about. All right, let's plug this in. This, no, maybe that capacitor is too big to respond to such spikes. I would have preferred the scope. Now I'm annoyed that I can't find the power adapter for it. And I have to go to the store, can you believe, and find a generic USB charger? And then find it a week later, right? Ah, it's annoying. It's in here. How do I not keep the adapter with the device? No better. Anyways, where's my meter? It's my regular power meter here. Had it a moment ago. Trying to find out where my power meter disappeared. My voltmeter of the power meter. So many meters in here. Meters here, meters there. Probably staring right at it. That's why it's getting late. I was doing it right here, showing everyone. That's odd. It fell between the table or something when I was moving. The meter here. Sorry about that, folks. Just trying to find where I put my voltmeter. Where's the voltmeter? That's funny. Like disappeared, teleported itself. Ah, right here. Silly me. Okay, there might be a residual voltage in that. So, go right here. As flimsy as this is, it might demonstrate the point. Again, my apologies, this is just on the spot. Don't have any real expectations. Okay, so now I see 0.20, 0.21, 0.2, anyways. As you see, a little bit of residual there. So I'm going to try and pulse it now. I wonder if it's going to do anything, if it's strong enough. Not exactly the setup I wanted to show, but yeah, this is not at all. I wanted to show it on the scope. To the drawing board here. Scope, scope, scope. Why is my scope being so stubborn? Sorry, folks, just looking around for that power adapter. It wouldn't be too far away. Yeah, it's live, so bear with me. I've just got this place, it's all new setup, so not everything is connected and ready to go, as you can see. I'm trying. If I plug the old one in there. And we have all right, let's see if this old one works. I'm gonna see if I could actually change the camera view here so you guys can, for the moment, see the scope view, such as it is, if I can get it going. Here's my power cell. Let's see if we pulse it. There it is. Saw that right away. It's been a while I've used this one. Change the polarity. There we go. It's going to bring this in the right focus. But yeah, it seems to be working, folks. There you go. As I pulse it to this one, you can see it there. I don't know if you can see it on the. But when I pulse it here, just direct here the scope, you can see the pulse. because there's like a 1-volt potential there. So true. So let's try this one step at a time. Through the coil now. Now this connects. This one here. Yeah, you see when I pulse it, this is the low voltage side, so it's a very small line. But when I tap it, there it is. We can zoom into that. Let's see. So that is working. So now let's keep our high impedance path. I'm stubborn and I just want to prove my point, okay? I'm sorry. So this and goes along in this one here. And then we pulse from the high voltage side into the scope here of this high voltage transformer right over here. Now, there it is. I'm going to zoom out now. See those high sharp spikes when I pulse it? That's exactly, it's like the equivalent of those Bedini sharp spikes. And that high frequency, you know, you got a lot of those. And that's charging capacitors and you're running cap dumps and everything. And we're talking about, you know, like 100 volts, 150 volts here. This is a 6,000 volt transformer. So even at like, and what's happening when we're doing this, because we're going through the high Z side of the primary transformer here, see, you've got a dual L, essentially primary system, to make the whole thing high Z on the primary side, so you don't drain your potential well over here, right? So to show that, I could put my voltmeter here, and we did all that, and you see there's that 0.97, still 1 volt here when I measure it, because we essentially didn't short it out, so it didn't go down. So exactly like Tom Biernan was saying, and this is now that I got it connected, I could show you folks, this is what he means. So now, just automate what I'm doing here, with some free source, the wind, the solar, environmental, piezo. Like I said, even if you want to pay a little bit for a trigger, a switch, a 555, like I wanted to do, mechanical clock needle. As long as that pulse is going, you're getting that spike here and it's coming in that high voltage. See? Very high voltage sharp spikes. And this is the fix, so that the system can feed the primary side without being actually low Z to actually short it out as you're pulsing it. It preserves it, it keeps your potential well, and you're not collapsing the dipole because we're keeping the loop open with the switching. So this at high frequency, of course, invites the environment to resonance and other nearby frequencies. And so yeah, this is gonna turn this back around here towards me here. But yeah, basically on the spot with Joel, right? But that's what I was saying, folks, you know. This is just an example right here, but there's your potential well, which lasts essentially forever. You just know how to trigger it properly at the right frequency that will forever charge capacitors, which could dump and give you real current back into battery storage devices. And if, let's say you have like 20 of these, and they're all strategically pulsing, that's running a cap-driven motor, pulse motors. which can then drive a smaller generator. And on and on and on it goes, right? I mean, it's just an example. I'm not claiming commercial quality power with a peg cell or anything like that. But, essentially an example again of cross energy domains. And that's where the magic happens, right? When you go from one domain to another. So, and don't collapse the source, like Tom Bearden would say. Whatever, however you want to do it, don't collapse the source. So electrically, very crude and fast, I just showed you a way of not to do that. But of course, one can build upon those foundations and apply it with other systems. I just used the peg cell because it's just what drew me. We were talking and there they were in front of me and I measured it just for fun to realize, oh, I'm still getting a volt. And it's basically 2 years later. It's been in here in my drawer, not even corroded or anything. So, yeah, a lot of fun in all of this. And again, I hope that you all, whoever's interested, enjoy the AI for as long as it works. And wow, it's already 11:38 here. So I will say good night to everyone. And thank you for watching. And I'm sorry for the little glitch here, just because I now it bothers me that I can't find the power supply from my new scope. But we had the backup. Old Betsy here is big, heavy, and green screen CRT, but still works when we need her, right? So, lesson here, don't throw away old stuff if it still works. So with that said, folks, have yourselves all a great night, and thanks for watching as usual. And thank you very much.